Hi, welcome back to the channel. So in this video, we are going to see PN junction diode, PN junction diode in forward biasing as well as reverse biasing. First, we should know how the symbol of PN junction diode. So here it is a diode means di means two. It is electrodes. So we should write the symbol of diode like this, where one electrode is P and another electrode is N. So it is called as two electrodes. So it is a name diode, and also it is called as PN junction because it is P type and it is N type. So it is a semiconductor diode. So semiconductor diode, you know that it is a diode which is material which is either a conductor, sometimes it behaves like a conductor and sometimes it behaves like an insulator. So now we should see how this PN junction diode will works. For that we will take the construction of this PN junction diode where it is P side and this is N side. In the P side, we know that the majority charge carriers as holes. So I will draw these holes. And in the N side, the majority charge carriers as electrons. Right? And here, this is a junction part. In the P side, the negative ions are accumulated. In the N side, the positive ions are accumulated. Under which condition? Under equilibrium condition, right? So for this construction of PN junction, which is having P and N type, we should give the biasing. How to give the biasing? Take this two electrodes. This side is positive and this side is negative. So it is a positive voltage. I will write it as V, right? Now, if we give this biasing, what is the effect on this P type and what is the effect on this N type? We'll see. Suppose if it is P side is connected to this positive terminal of the battery, these holes will start moving in this direction because this plus and plus, they are same charges, they will start repelling each other, right? Similarly, come to this N, electrons are there, electrons are here. One second, one small mistake here. Since it is P side, majority charge carriers as holes, these holes are getting attracted by this negative side of the battery. So this concept, positive is getting attracted by negative, so the holes will start moving in this direction. This N side, we are having the electrons. These electrons will start moving in this direction and getting attracted by this positive side of the battery. Right? When the holes are moving in this direction and the electrons are moving in this direction, and there is an effect on this region. This region is called as a depletion region. And however the amount you are giving this V, the voltage, assume that initially the voltage is low. At that time, the depletion region size is like this. Assume that at the later stages, this voltage is high. So this depletion region, this becomes narrow like this. And this Vf becomes very high, this becomes a very narrow, so that the electron conduction current is going to be produced due to the majority charge carriers. In the P side, holes, in the N side, the electrons. Because of these majority charge carriers, and this depletion region become narrow, these holes are attracted by this negative, these electrons are attracted by this positive, and there is a current which is in the reverse direction of this electron's movement. Electron will be moving in this direction. So the current is going to be like this. The current I is called I. Since this type of a structure, if the positive is connected to positive, negative is connected to negative, this is called as the type of biasing, that is called as forward biasing. So we will write it as VF, I we will write it as IF, right? So we got the two components V and I. So however you will increase the V, the same current I will increase. So it is forward biasing, forward current will produce, right? So symbol, this is a construction, and we should write the VA characteristics of this forward biasing. So how? We'll write the V in the x-axis, we will write the I in the y-axis, right? So how the characteristics will be? Initially I told V low, the current is going to be low. So V will start increasing, the current will start increasing. So it is going to be like this, right? So here the point where it will start exponentially increasing, that voltage is called as knee voltage. That knee voltage is going to be V knee is going to be 0.7 volts for silicon and 0.3 volts for germanium, right? For silicon 0.7, 0.3 for germanium, means at this voltage the current is going to be increasing exponentially, that is the meaning. Suppose if you want to take the slope from this, you can take the slope like this. This value is IF and this value is VF. This is the slope, right? So this is a forward biasing VA characteristics. Now we will see the reverse biasing VA characteristics. So in case of reverse biasing, here everything changes. So we'll see that here. Okay. So in the reverse biasing, we will see which are the charge carriers which are responsible for the flow of electricity. So here for that same PN junction, but the construction is going to be different. Just look at this. I will write like this in case of the reverse biasing. This is P side and this is N side. So here it is, look at the polarities of this V. I have taken this as negative and this as positive. Here the majority charge carriers as P, the holes are there, and here it is electrons are there. So here P side, what you should write? The negative ions. So intentionally I have written this, the width of the depletion region the bigger compared to the previous. N side write the positive ions and it is negative ions, right? So majority charge carriers like this. So here, since the majority charge carriers are positive here, these will be attracted by negative side. And here the majority charge carriers are electrons which is attracted by positive side. So what is the status of this depletion region? It is getting wider. Initially it is like this. Since its attraction will be like this. For this, here it is, and for this, here it is. So it is going like this. Holes negative, electrons positive. It is like this. So this depletion region widens. In case of what type of biasing? In case of reverse biasing. So this I will write as VR, right? Because of this, now here the role of minority charge carriers plays. In the P side, which are the minority charge carriers? These are the minority charge carriers, right? In the this, which are the minority charge carriers? These are the minority charge carriers, right? So these minority charge carriers, now it is minus, so it is trying to move this side, and it is attracted by this positive, and here the minority charge carriers as plus, these will move here and this will attracted by minus. Because of this, the current generates, and that current we will call it as IR, reverse current. How the electron movement is? So the electron movement is in this direction, right? So here look at this electron, minority charge carriers in this direction. So how the current is in this direction, right? So now for this we should write the VA characteristics. So VR increases, the current IR increases, because we know the Ohm's law, V is directly proportional to I. Since it is a reverse, it is a reverse current. So how to draw the VA characteristics? Since it is a reverse, we will take the assumptions. We will take the assumptions of these V and I which are reverse, that is in a third quadrant. This is first quadrant, second quadrant, third quadrant, fourth quadrant. So we'll take these assumptions in the third quadrant, and we'll consider in the third quadrant both as negative, right? So initially, so I will write this as VR and this as IR. Initially, when VR increases, the current will increases to some up to some extent, and this is the curve like this. VR increases initially, IR increases, and it will reach the saturation stage where we will call it as I naught, and this current becomes a constant. We will call it as, this is a current I, and it is called as reverse saturation current. So it will be constant after this some initial VR voltage. So VR, if you try to increase, and your current I becomes constant. So that's what we are done here. Then after this voltage, if you try to increase this VR, this current will be we'll call it as, it is exponentially decreasing, and at this stage of VR, the PN junction breaks. This is the region. PN junction breaks, and the voltage which corresponds to PN junction breaks is called as breakdown voltage, that is VBR, right? So that is what here is. So this is a VA characteristics of reverse biasing. In the reverse biasing, this is the diagram with respect to construction, and this is a VA characteristic. Suppose if I want to draw the complete VA characteristics, how it is? The complete VA characteristics, we can observe how we can write. You see the complete VA characteristics, complete VA characteristics of PN junction diode. So we will draw the four quadrants. Very important is first and third, right? In the first quadrant, we should draw the forward characteristics. In the forward characteristics, two important parameters are VF and IF. So this is corresponding to forward characteristics. How we have drawn this origin? Initially, if we start increasing the VF current IF will increase like this, and it is exponential. So this point we have mentioned it as knee voltage. So voltage at which the diode will start conducting, right? So we know that this is 0.7 volts for silicon. For germanium, it is 0.3 volts, right? So in the third quadrant, how to draw the reverse characteristics also is here. Initially, we can write this as VR and this as IR. Initially, when the voltage start increasing, the current will increase. Later, if you start increasing also, it becomes constant. Then after some voltage, the diode breaks. So this we have written as I naught, that is the reverse saturation current. Reverse saturation current is almost constant. Then after this, some voltage, we call that as a reverse breakdown voltage. At this voltage, the diode stops conducting and it breaks, right? So this is a complete VI characteristics of PN junction diode, right? So thank you. We'll see in the next video of the next update. Stay tuned to this channel for the latest notifications. Click on the bell icon. So here, put it in the comment section if you have any doubts on the PN junction basics. Thank you.